In this video, we're going to be talking about the intermediate value theorem. It's what's called an existence theorem, so it's simply just telling you that something must exist if we use this theorem. This is a good little diagram to describe it. If I'm using inputs or x values and plugging them into a function, then I'm getting outputs or I'm getting values of a function. If I plug in a into a function, my output is described as f of a. If I plug in b, my output is described as f of b. An input that's in between a and b can be described using the variable c. That's just another input variable. So c is somewhere in between a and b. And if I plug it in, I get this output. We could call it f of c if we wanted. And so the intermediate value theorem is simply saying that if I plug in an input that's between an interval or endpoints a and b, then I get an output that must be in between the outputs given by my endpoints. So f of a and f of b, and that f of c must be right in the middle. Not necessarily right in the middle, but anywhere in between. It is worth noting that it says at least one. So in this diagram, we see that it can happen once. However, it could be more complicated. This graph could be going up and down a bunch of times, and we could have multiple outputs that are in between these two outputs. So it just has to have at least one. It could have more. So if you want to see more diagrams and more explanation where it gets a little bit more complicated there, go to this link, and they do a nice job of describing and showing more examples. But essentially, it's this statement. The output given by plugging in A must be less than some random input that's between A and B, which must be less than this output given by plugging in B. So if I plug in A, I get this output. If I plug in B, I get this output. And if I plug in C, I must get an output that's in between those two. In general, you see two types of questions dealing with the intermediate value theorem. One main question has to do with just using it to prove that a value exists. The second type of question would be something like finding that value. So what is that input that is between those two, A and B? So just proving that it exists or actually finding the value once you've proven that it exists are the two types of main problems that we see using the intermediate value theorem. Let's try out the first one. Use the intermediate value theorem to prove that a value exists. So we can use the intermediate value theorem to explain why the function right here, x squared plus 3x minus 6, must have a root on this interval, which is talking about inputs. So if I plug in values between 1 and 2, one of those outputs must be a root. Let's remember that a root is just an x-intercept. So somewhere between the inputs 1 and 2, I must be crossing that x-axis. Let's prove it. So we remember that a root is an x-intercept. If I have an x-intercept, then my y value is 0, or the output of my function is 0. If I'm sitting on the x-axis, my y value is 0. So we can set our equation equal to 0 if we want to find a root. It's the same thing we do if we want to solve it, because they're the same thing. If I plug in 1, then I should get an output, and that'll be represented by g of 1. If I plug in 2, I should get an output, and that would be represented by g of 2. There must be some input in between those two outputs that gives me a root value, or should be a solution to this equation. So let's check the endpoints first. If I plug in 1 into my equation, we get 1 squared plus 3 times 1 minus 6, which gives us a value or an output of negative 2. If I plug in 2 to this function, we get 2 squared plus 3 times 2 minus 6. That gives us an output or a value of 4. So if we go back to that inequality that we described and just replace the output value of negative 2 for g of 1 and replace g of 2 with 4 and think about it, is there a root or do we cross the x-axis in between negative 2 and 4 on a graph? Well, of course, if we're going from negative to positive, at some point we have to cross the x-axis. So we just use the intermediate value theorem to prove that it exists. We're not talking about what is that input, although that'll be the next question, but just does it happen? And we can prove it by just using that inequality statement. G of 1 is less than G of C, which is less than or equal to, sorry, let me say that one more time. G of 1 is less than or equal to G of C, which is less than or equal to G of 2. And when we replace our values, we know that negative 2 is less than or equal to whatever this value is that's going to be our root, which is less than or equal to 4. It must cross the x-axis if we're going from negative to positive. And you can plot it on a graph, and you can really visualize it if you'd want. But all we wanted to say is just does it exist? And the intermediate value theorem does support the value, and it does exist somewhere in there. We just don't know what it is. So the second type of question you might see with intermediate value theorem is actually finding that value. Not just does it exist, but what is that value? So we're going to do an example of that. Verify that the intermediate value theorem applies to the indicated interval and find the value of C, guaranteed by the theorem. So we have this function. We're given the interval or the inputs that we want to try out. And then we're told that some input is going to give us a value of 4. And so we want to find what that input is that gives us a function value of 4, or set this equation equal to 4 and solve. And then we're just going to make sure that that input that we found that existed is actually on the interval between 0 and 3. So let's set the equation equal to 4. We're told we have a function and we want to set it equal to 4 and find the input that gives us that. In order to solve quadratics, we want to set the equation equal to 0. Sometimes we could factor to solve it. So if I get the right side equal to 0, I'm going to subtract 4 from both sides. Now I have my quadratic set up to solve. X squared plus x minus 6 equals 0. And now I can factor it. If it's not factorable, you can still solve it using the quadratic equation or the quadratic formula. Or you could look on your calculator and just graph it. Look at your data table or look at the graph. So we know that zeros here are going to be negative 3 and 2. Those are actually solutions or x-intercepts. And we wanted the one that was in between 0 and 3. Which of these solutions is on that input interval? Well, negative 3 isn't, but positive 2 is. So we'll just pay attention to positive 2. So the function is equal to 4 when that input or C value is 2, and 2 is on the input between the intervals 0 and 3. So let's go back to the original question. It said verify that the theorem applies to the indicated interval. Well, yes, we did prove that a solution to this function that equals 4 was given by an input of 2. And 2 is on that interval from 0 to 3. So there are two of the types of problems you may see when using the intermediate value theorem. It's either, can you use the intermediate value theorem to prove that something exists? And can you actually find that value? So good luck using the intermediate value theorem to answer some questions.